The next major scheme function for list is cons. Think of it as a way of adding to the front of the list. Now, the con node itself acts like a linked list with a few interesting features. The node becomes really two pointers to two items. Now, I have to be kind of vague here because the item could be a list or an atom or a single element. Now, one pointer points to whatever is in argument number 1 in the statement, as you see below with cons 1 and then list 2, 3. The other pointer points to whatever is in argument number 2 in the statement. Now remember, argument 0 is cons itself, so that's why I have to go 1 and 2. Notice a minor but important difference of adding either an atom or another list. In the two examples that I have for you, the first two, you'll see the difference between the two. Is that cons node, the pointer setup remains the same. Just notice the results. If we're inserting a list, it now contains an inner list, whereas if it's just a single atom, it's pretty much a flat list. Also, if you look at the third example, an empty set or an empty list is a legit value. So here we're going to add a list A into an empty list, so the overall answer is going to be just A. It's a single list, flat list. Here's all my different examples that I have for you. The almost very last one and the last one, that one's kind of easy, but the almost last one's a little bit more interesting. Just remember that cons itself, think of it as a node with two pointers no matter what. It's just what is it going to be pointing to is the real key issue here. The interesting part about this is that we can also use multiple cons. Well, just think of the exact same thing, it's just linking two lists together, but the results are going to be different. In my multiple con example here, the first line of cons 1 and then the list of 2, 3, you see the results a little very simple. It's a list of 1, 2, 3. Now remember, 1 is an atom, so that'll be inserted into the list. The other one's a little bit more interesting, and I want you to try to draw that one out. Now notice I am showing you the result on this. The result kind of gives it away what's going to happen, but I want you to draw it anyway. Remember what cons is doing. Cons is just a pointer to two items, either an element or an atom or a list. So go ahead and draw this out. Hit pause here, and I'll show you the answer here in a moment. So here's the answer for adding two cons to the numbers 1, 2, and 3, 4, and then you had an outer con for the whole thing. Notice again, we had 3 cons, so we know we have multiple nodes that have multiple set of pointers to it. We obviously go with the inner set first, with the 1s and 2s, I'm going to have to do that first, and then 3 and 4, and then we're going to con those two items together.